Real-time comprehensive protection across digital attack surfaces and cycles is very important in the new cyber norm. And that's what Fortinet provides companies around the globe. And we are fortunate to have here with us today the systems engineer at Fortinet Philippines to tell us how to apply artificial intelligence in cybersecurity operations. Our next speaker has over 10 years of experience in IT solutions, selling on various technical roles, specializing in network and cybersecurity. Please welcome Fortinet Philippines System Engineer, Mr. Fredric.
Fortinet gives you the confidence of knowing that wherever you are, or whatever screen you're on, and whatever situation you're in, your people, devices, and data are always secure. Fortinet, digital security everywhere you need it.
Good afternoon, everyone. I'm Fredric Systems Engineer from Fortinet Philippines. I'm going to talk about the future with AI, machine learning, and internet-connected devices. This is in context with the artificial intelligence technology we applied to our cybersecurity solutions. Artificial intelligence, or AI, is almost 100 years already. It was invented in the 1930s by Turing, Klein, and Church. They proposed a machine learning solution. Back then, computers were quite simple and not that powerful. But as time goes on, computer technology improved and evolved in terms of processing power and capability. So today, AI is almost present in our lives every time, whether we know it or not. For example, the navigation apps that we use to go places from a source to a destination, AI creates decisions to route us through the least distance or the least amount of time. Another application is video conferencing apps, which is enabled us to, for example, change our background. So the AI is able to distinguish our heads and our bodies from the background. Fortinet leveraged AI to combat modern cybersecurity threats, which is also leveraging the same technology. So with modern threats, they can be dynamic, they can be very hard to detect, for example. With machine learning and AI, we're able to learn patterns of those malware or attacks so that we'll be able to properly identify and classify them. The primary product vision of FortiAI is to mimic human-intensive functions such as malware analysis and finding the source of an attack. With incident analysis, usually it takes someone with at least 5 years experience and a few years time to get down to the bottom of the root cause. In a breach situation, time is quite critical, and we all know one of the hardest things to buy is experience. The second goal of FortiAI, it addresses reducing the time to detect from minutes to sub-seconds. This might not seem significant at first, but it's crucial when it comes to breach investigation. Minutes to seconds can mean if you can stop the spread of the infection or not. Let's look into an overview of the malware evolution. Fortinet, like many security vendors, started with signature-based detection, which has its pros and cons. Before advanced threat evolves, a virus equals to a hash for detection. However, this approach is compute intensive and cannot cope with the volume of malware incoming. About a decade ago, threats evolved and became more advanced, evading the simple detection, and automated malware analysis such as sandboxing started to evolve. Malware variants start to form new ways and means to spread across the network. Malware, or malicious code, almost exists in anything that is software-based, from nuclear plants to IoTs. However, hackers' world kept evolving. Hackers started to use machine learning for malware generation and modification. Vendors such as Fortinet also started to use machine learning to combat machine learning, aiming to improve detection rate, scientific analysis to bypass human errors, and more importantly, to reduce detection time to sub-second. Also using mimicking human intensive functions such as breach analysis with virtual security analysts. So we are already in the third generation of threat detection and prevention. The first being signature-based, second being advanced threat protection or sandboxing, and third AI. So all of this needs to work hand in hand so that we can provide a confidential protection for our customers. There are many methods of detecting malicious code. First is using the AV engine, which inspects the core of the apple. Second is using the sandbox, which takes a bite on the apple. Third is using FortiAI, which describes the apple if it's rotten or it smells, for example. Fourth is the FortiDeceptor, which places apples in certain locations, which enables us to detect who or what the threat actor is. The focus of our discussion here would be the FortiAI, which enables us to detect malicious code, which is analogous to an apple, if it is characteristically bad. Like for example, it doesn't look good, it smells, for example. So this is actually a method that doesn't need any sampling or testing. So we just look at the attributes of the file, for example, based on the detection capability that we already have or learned before. With machine learning, there's a concept of features. The simplest explanation is like how we teach our children how to identify ducks, with features such as feather, color, or the sound it makes. FortiAI does the same with malware. With enough training, it can be taught how to identify malware and clean files. FortiAI's machine learning is aimed to increase performance, reduce detection time of sophisticated malware from minutes to sub-seconds. We have seen the progression of malware evolution. FortiANN or Advanced Neural Network evolves to learning from training and also on-prem learning from customers' traffic. It's also a business outcome focus based on virtual security analysts, mimicking human-intensive functions and experience, such as classify malware and tracing the source of infection. FortiAI is part of the Fortinet security fabric. It has two modes, integrated mode and sniffer mode. Sniffer mode supports scanning of large amount of HTML or web-based traffic up to 100,000 files per hour. Supports HTTP, GET and PUT, as well as SMB protocols. FortiAI can support both sniffer mode and integrated mode with FortiGates. With integrated mode, it can support more protocols. Anything AB profiles can send. And also using FortiGates as a decryption for encrypted traffic. Now let's just look at the virtual security analyst capabilities. Often when an enterprise is compromised, the SOC or Security Operations Center will be busy cleaning up infections and restoring backups. Security analysts will run cross scans of viruses or even upload the virus total. They do that because they want to understand the clean malicious verdict, which like virus total can tell them. But what virus total doesn't do is tell you the nature of the malware, whether it's trying to steal passwords, a downloader that had downloaded something else, for example a worm. Usually enterprise or even a mature MSP doesn't have malware researchers. Therefore, FortiAI provides a years of malware research experience in a solution. FortiAI VSA has the ability to classify the malware based on what it has seen before, even if the malware is trying to disguise itself. If you talk to some of our most senior researchers in FortiGuard labs, they have the experience where a malware will fake itself as a ransomware, with a ransomware screen or note. But it's actually a downloader which downloads more malware or backdoor into your network. In a human analysis, a human might make mistakes on the analysis, but VSA won't, as it's scientifically analyzed on machine, and analysis of the malware also is more effective because of the previous learnings that it already have. Another key function for VSA is the ability to trace source of the attack. This is crucial function during the outbreak. Often enterprises are busy with cleanup and it's difficult to find source of the attack. FortiAI will sniff traffic on the network and draw conclusions based on the network history. Malware like WannaCry spreads via SMB. Imagine how a human brain thinks. If you see a similar malware on host 2 on the same network, you might draw conclusion that the spread of the malware from PC1 to PC2. This is exactly how FortiAI works. The screenshot in white is an output of FortiAI BSA scenario-based engine, where it concludes that there are worm activities spreaded to two different hosts. While there are worms activities observed, one might ask, where does the worm come from? BSA can answer this question. If you observe the timeline carefully, the worm came from the downloader, which is downloaded by the dropper, drops a file on the network. The dropper originally came from some HTML web-based traffic, which has some fake JavaScript inquiries. This is the original worm that spread across the network. Now let's take a closer look at how FortiAI works. These are some of the stats of the ANN or Advanced Neural Network and Virtual Security Analyst. While in FortiGuard Cloud, VSA exposed to around 200 plus billion malware features. In the FortiAI solution, we extract the highest quality features, it's around 6 million, onto the appliance while maintaining the best detection rate. This is an on-premise solution that enables a customer to have on-site machine learning capabilities, which enables them to detect and even prevent zero-day and emerging malware. It can even detect and prevent fileless attacks. Under the hood, FortiAI has a patent-pending artificial neural network responsible for classifying the files, and scenario-based engine mentioned earlier for tracing source of the attacks. The state of the ANN is pre-trained in FortiGuard labs with about 20 million clean and malicious files and can be further trained at customer site. To understand the ANN, you can imagine each node is a job for a junior analyst, trying to determine if a code block matches any known malicious behavior. The input of the ANN is code blocks and output is verdict of the file, clean or malicious, based on the features observed. Also important to note that there's no need to run the file like traditional sandboxing. This cuts down reduced time for processing. These slides illustrate the flow with FortiAI detection. In sniffer or integrated mode, FortiAI will receive files on network, whether they are executables or scripts or HTML traffic. It will go through stages. Feature extraction. This is where FortiAI will engage the executable engine and text-based engine, deobfuscate and unpack malware. Then a typical file will be, on average, broken down into 5,000 plus code blocks. Note that this is almost in assembly or instruction level. And these code blocks will enter the pre-trained neural networks, which will use its custom hardware to accelerate processing. In conclusion, FortiAI will scientifically classify the malware based on feature count, whether it is info stealer, coin mining, ransomware, in disguise, or other things that are malicious. FortiAI can detect fileless malware, which is a more modern term for malware that is more elusive for detection. Does it have any footprint on hard drive? Is it fileless? Might even encrypt or decrypt itself in memory, which makes it very difficult for traditional vendors to detect. Most of them utilize PowerShell or scripts to execute. In the next slide, we will find out how FortiAI detects them. To understand fileless malware, first we have to see how it actually gets into the network in the stage of the attacks. Which is not surprising, hackers might lure users to links, exploit the existing programs such as Microsoft Word. Then, the computers are instructed to run PowerShells or JavaScripts to download further malware. Once infected, the downloader can download anything. Malware can utilize spreading throughout the network. FortiAI is effective in detecting downloaders and droppers effectively. These are 2 of 30 plus attack scenarios FortiAI can detect. Once malware executes and encrypts itself in memory, many vendors will struggle here. FortiAI is also effective when detecting the spreading of the malware and tracing the source. Within FortiGuard Labs, FortiAI will be trained to about 20 million plus of clean and malicious files via feature extraction. The advanced neural network classifies the features and places them in a features database. Note on box that there are no AV engines. With the new malware that are being identified every day, in fact, every day, FortiGuard Labs sees about 200 plus thousand net new malware. FortiGuard Labs will retain the ANN and provide updates via FortiGuard. With the result of the training, neural networks which powers VSA or the Virtual Security Analyst can be as good as humans. The chart you are looking at shows how FortiGuard Labs measures quality assurance. In blue line represents FortiAI neural network, which is trained continuously to improve detection rate. The darker line represents the detection rate of human analysts, the signature written by humans. You can see over time FortiAI is on par or even better than humans. In the next slide, we'll touch on the on-prem training. One of the unique features in FortiAI and ANN is self-learning capabilities. This is how it works. First, FortiAI comes with pre-trained clean and malicious feature DB or database. These are used to classify clean and malicious files. Then, it also comes with a customer or on-prem feature database, which is empty. In 2A, in action, FortiAI will detect, in this case, a malicious file on customer's network using existing pre-trained features. Third, at occasions in a file averaging 5,000 plus code blocks, FortiAI might or might not have seen the new features. Next, going to 3B and C, because the file itself is malicious, it is very likely that new features observed are malicious. FortiAI places a higher weighting to the new feature learned, and placing them in customer feature database after customer features and Fortinet feature database are both used to determine if it's a new incoming malicious file. Why is this useful? If you consider every customer enterprise, vertical traffic are different. The ability to self-learn and adjust is important. Fortinet files and the bank files are completely different, for example. Another reason why most vendors' cloud AI model fail because it's one size fits all, which is never the case with the FortiAI. Lastly, how do we protect internet-connected devices? With FortiGate combination with intelligence from FortiGuard and FortiAI, we can better protect against known threats. Some of these threats are virtual patching for hard-to-patch assets, protect against known vulnerabilities of these devices, protect against zero-day vulnerabilities using FortiAI and machine learning, intelligent virtual security analysts to provide incident investigation and subsequent verdicts on detected incidents. So in summary, all of our solutions are geared towards protecting all threat vectors, known and unknown. This concludes my presentation on AI and machine learning technology of Fortinet. Thank you.